Let's talk about derivatives of trig functions. So in the past, we learned a couple of basic derivatives. We know how to differentiate monomials, and we know how to differentiate constants. And in previous sections, we've learned how to combine monomials and constants to find derivatives of polynomials, to find derivatives of rational functions. But now we want to learn a few new basic derivatives, which is derivatives of trig functions. So the derivative of sine of x is cosine of x. And the derivative of cosine of x is negative sine of x. Okay, so these are definitely important things that we need to memorize. So I'm going to highlight these. Uh, you know, it's beyond memorizing it. You really need to know it. So it's like you didn't memorize that there's 50 states in America, or there's 7 days in a week, or there's 52 weeks in a year. Those are things that you know. So we need to know these derivatives really well. All right. We'll definitely look at some examples in class. I wanted to take a look at example 4. So example 4 says, using the derivative of sine x and cosine x, find the derivative of f of x equal to tangent x. So we're going to write f of x equal to tangent of x. And what we're going to do is we're going to use the quotient identity. The quotient identity for tangent of x says that that's equal to sine x divided by cosine of x. So we're actually going to differentiate this quotient right here. All right. And in order to differentiate this quotient, we're going to need to use the quotient rule. Let's remind ourselves of the quotient rule. The quotient rule said that if you had the quotient of two functions and you want to calculate its derivative, it's the derivative of the top function times the bottom minus the derivative of the bottom function times the top, all divided by the bottom squared, right? So let's do that with our tangent. So when we differentiate our tangent function, the derivative of sine we saw was cosine of x. Then we want to keep the bottom, we want to multiply by the derivative of the bottom function, which is cosine of x. Minus, now we want the derivative of the bottom function. The derivative of cosine of x is negative sine x. And then we want to multiply by the top function, which is sine x. All divided by the bottom function squared. The bottom function is cosine, so the denominator would be cosine squared x. Okay? Now, we see that we have a negative times a negative in the numerator, so that's going to make that positive. And when we simplify the numerator is going to be cosine squared x plus sine squared x, all divided by cosine squared x. When we look at the numerator, cosine squared x plus sine squared x, this is one of the most famous Pythagorean trig identities. That's equal to 1. So we get 1 over cosine of x squared. Now, we're going to use the reciprocal identity. Remember, the reciprocal identity, let me write it off to the side over here. Secant theta is equal to 1 over cosine theta. This means that secant squared theta would be equal to 1 over cosine squared theta. So really, this derivative of tangent is really going to become secant squared x. So now we've just solved for the derivative of tangent, and I'm going to write it in this theorem we see on our screen here. So we get secant squared x. Okay. So I want to now tell you the derivatives of the remaining 3 trig functions. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x times tangent x. And the derivative of cosecant is negative cosecant x cotangent x. I'm also going to rewrite the two derivatives that we had talked about earlier. So the derivative of sine of x, remember, was cosine of x. And the derivative of cosine of x was equal to negative sine x. And as I said earlier, we really need to know these. And I want to help you, think about the relationship between all of these derivatives, and that might help you remember them more easily. So the first thing I want you to notice is that the derivative of anything that involves a like cotangent, cosecant, cosine, they always have a negative in front. All right, so let's write that down. Derivatives of co-functions are negative. Okay, that's the first thing I want you to notice. The second thing I want you to notice is that when you look at trig functions, they oftentimes come in pairs. So sine x and cosine x, those are like cousins or brothers. And when you look at their derivatives are really related to each other. Like they're each other's derivative. So cosine, this derivative of sine involves cosine, the derivative of cosine involves sine. Okay. The second thing I want you to notice is that tangent and cotangent, those guys are also sisters. So if you look at the shape of their derivatives, the shape of their derivatives is like something squared and something squared with that negative coming from the co-part. The third thing I want you to notice is that secant and cosecant are also cousins, brothers, sisters, related. And when you look at the shape of their derivatives, they're products of two trig functions. Not only are they products of two trig functions, but one of them has secant and one of them has tangent, and then the other one has their sisters, cosecant and cotangent, right? If you look at the derivatives of tangent and cotangent, one involves one of the sisters, and then the other one involves the other sister. So there's actually all these relationships between the derivatives. They're not just randomly situated, I guess. So I guess I want to mention that the shapes, I'll put that in air quotes, of the derivatives of related trig functions are the same. All right, everyone. We'll look at a bunch of examples in class together. Take care.